Okay, this is question number 5 now from that packet. So part A is to estimate f prime of 4. So 4 would be right between 3 and 5. So we're going to use the points 3, 4 and 5, negative 2. We're going to do y2 minus y1 over x2 minus x1. And we get negative 3 as the answer, and that was worth 1 point. Okay, and I just want to say that only took 30 seconds to do. So part B, so we did part A. Oh, let me get my pen back. Today now we're doing B, and so this is a time that it would be good for you to break it up into 2 integrals. So we'll do the integral from 2 to 13 of 3 dx, then minus the integral from 2 to 13 of 5 f prime of x dx. Okay? So let's do one at a time. Let's start with this one because we don't have a lot of room here. Well, actually, you know what? I can go to the next page and do that, but that might kind of confuse you. Okay, so the antiderivative of 3 is just 3x as it goes from 2 to 13. So you're going to put 13 in there first, and you're going to get 39 minus, and then you're going to put 2 in there and you're going to get 6, and so you're going to get 33. So this piece over here is 33, okay? So we're going to do 33 minus whatever the next piece gives us. Okay, I'll go back to my red. Okay, so now we're going to do this one right here. Okay, so I'm going to pull the 5 out to the front of the integral. Sorry about that. Okay, so now I have 5, and now I'm going to do the integral. So the antiderivative of f prime of x is just f of x as it goes from 2 to 13. Okay, so I'm going to go down here. So I have 5. So I'm going to do f of 13 minus f of 2. And what do you know? That's what this chart is from. So f of 13 is 6 minus f of 2 is 1. And I get 5 times 5, which is 25. So this piece over here was 25. So we have 33 minus 25, and the final answer will be 8. And the point values are as follows. Okay, this, setting up the 2 integrals, showing it like this, that was worth 1 point, and then getting the answer was worth 1 point. Okay, and that is part B, so that's done. Let's check that one off. Okay, now we're up to part C, and we're going to use a left sum with the subintervals that are shown. So the intervals that are shown are going from 2 to 3, from 3 to 5, from 5 to 8, and from 8 to 13. So we're going to have 4 intervals. We're going to use left, that's important, to approximate the interval. Okay, so for this first one, the length is 1, 2, 3, and 5. Okay, so if I'm looking between 2 and 3 and I want the one on the left, that's going to be the 2. So the y value is 1. And from 3 to 5, the y value is going to be 4. And then we're going to get negative 2. We're going to get 3. Okay, so we'll just multiply this all out. Okay, when we add them together, we're going to get 1 plus 8 minus 6 plus 8. I'm sorry, 5 times 3 is not 8. I'm a complete idiot. 15. Let's get this out of here. Okay, so 1 plus 8 is 9, 9 minus 6 is 3, and 3 plus 15 is 18. Okay, so where did your point values come from? The answer was worth 1, and then if you did these left sums, you got 1. Okay, but if you got one of them wrong, excuse me, then it just screws up, your whole answer. Okay, so we did C, and we just check that off. And now we're going to do D. Okay, so they're giving you some information, and let's see what they're telling us. So f prime of 5 equals 3, so that would mean that f of 5 is positive. Okay, may or may not help us, but then if the derivative was positive, that means that the function before had to have been increasing. Okay, so let's just write that in case we need it. So f of 5 was increasing, okay, because the derivative is positive. We're also told that the second derivative is less than 0, so that would mean that f is concave down. We may or may not need that. And all of this we're just talking about in the integral from 5 to 8. So just in this part here, from 5 to 8, okay? Let's clean this up a little bit. Okay, so what are they asking us to do? So use a tangent line. So the first thing I'm doing is running the formula. Okay, and then do it at x equals 5. So I know x is 5. This should have been the next one. Okay, and so to find y, well, when x is 5, y is right here, -2. So negative becomes positive. Okay, so far so good. This is not too bad. Okay, next we're going to need m, which is the slope. So we need the slope at 5. But they told you the slope at 5 is 3. Okay, so we just got that. And I'll just tell you now that if you did this, that bought you 1 point. Okay? So let's go back to the question and see what they're asking. So use the tangent line, so this was the tangent line, to show f of 7. Okay, so this is a tangent line approximation. That's what this is all about. So interested in when x is 7. Okay, so we're going to put 7 in there for x. Seven minus 5 is 2. And if you bring the 2 over, you're going to get that y equals 4. So we needed to show that f of 7 is less than or equal to 4, and we just showed that by showing that if we put 7 in there, that you would get 4, and 4 is less than or equal to 4. And that just bought you, well, this whole part really, that just bought you 1 more point. Okay? All right, let's make some room. Because there's a second part to this. Okay? Okay, now we have to use a secant line. Now, don't forget the secant line, and we started this when we first started derivatives, and I showed you, like, what if you have a curve like this, and you take the point here, and you draw the line, and we find the slope. So the secant line is just a line that hits it in 2 places, okay? So that means there's 2 points. And the secant line is going to come from 5 and 8. So what are our 2 points? 5, -2, and 8, 3. So y2 minus y1 over x2 minus x1 gives us 5 over 3. So that is the slope for the secant line. Okay? So now they're saying to show f of 7 would be greater or equal to 4/3 if you were to use the tangent line for that. So we have to do the exact same thing that we did before. So I'm just going to write over here that m was 5/3, so we don't forget that. Oop. Trying to get my eraser. Okay, so we do the tangent line all over again. Okay, so we already know that m right here is 5/3, so let's get that in there before we forget. Okay, so now which x and y are you going to use? Well, it doesn't really matter. You have 2 points. I'm just going to choose 5 because it's smaller, and if I have to do this by hand, it's just going to be an easier number to work with. So when x is 5, I know that from up here, y is negative 2. So I'm going to get y minus minus, which is plus, equals m x minus 5. So this is the equation of the secant line. And now we are interested in f of 7 again. So, and let me just point out, I'm just going to stop there before I erase, that if you did this, that was worth 1 point. Okay, so now we're going to put 7 in there. So what they're trying to do is to show you the difference, whether you use the secant line or a tangent line approximation. Okay, so just simplifying. 7 minus 5 is obviously 2. This will give you 10 over 3. I think I can erase this now. Okay, so if you bring 2 over to the other side, find a common denominator. And y will equal 4/3. Sorry. So we were supposed to show that f of 7 is greater than or equal to 4/3, and you can see that it is equal to 4/3. And so if you did that, well, all this work that we just did, that would have brought you 1 more point. And that finishes number 5.